Hi, everyone. I have started one new series for machine learning, that is machine learning with Python. And this is the lecture number 1 of this series. Although this series is mainly designed as per the practicals of machine learning with Python is concerned, but in this first lecture, we are going to discuss some theoretical concepts that is very important that we have to know the base regarding machine learning and some technical terms. So, machine learning, what is this exactly? So, you all know that this is a field of computer science with the help of which computer systems can provide sense to data in much the same way as human beings do. We all know that this our computer works primarily with the help of data as input. But the difference between the common programming, that is programming without machine learning, and machine learning based programming is that this type of programming can add sense to the data. And this sense is the same way as we human beings feel. So, in simple words, machine learning is a type of artificial intelligence that extract patterns out of raw data by using an algorithm, or you can say simply a method. So remember, this machine learning actually a subset of artificial intelligence. We discuss a lot about artificial intelligence, right? This is a, and you can say it's a human-made intelligence that we push to a machine so that this machine can. Sorry for the interruption due to the. Anyway, so let's again start. So how we are defining this machine learning? This is I just told you that this is a subset of artificial intelligence, and here we try to extract patterns out of raw data by using some algorithm. Simply, you can call it as a method also. So main focus is to allow the computer systems learn from experience without being explicitly programs or human intervention. Pension. Okay. So what does it exactly mean that this machine learning based systems will learn from the experience? And in that way, it will come to a state that it may not need human intervention. So, what is the need to make machine learn? If someone asks you, then the reason you have to say like that to make decisions based on data with efficiency and scale. Because uh, we humans are actually making these machines learn, right? To make decisions. And obviously, these decisions are going to be based on the data input. But the difference is that we human may make some errors. But if the machine is taught, or if the machine is, if we say that if we make them learn those things, those data, and on that based on the experience, means train them, then they can take much better decisions, or you can say much the accurate decisions than us, than any other human beings. This is the reason why we need the machines to learn. And what is exactly a machine learning model? We know about Professor Mitchell because he is the one actually who brought this concept. Although many other scientists and professors means they try to propose these things, how to make a machine learning. But initially we have to take the name of Professor Mitchell, and according to him, a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P. If its performance at tasks in T as measured by P improves with experience E. I'm again telling you, so here the three things associated: E, that is the experience; T, that is those are the tasks; P, that is performance measure. So this performance will improve over experience for any particular task T. Okay. Got it? So we have to know this task, performance, and experience definition more clearly. Now, we got it that these T terms are associated. So how we can define? First of all, look at this diagram. See task. Task means for that particular work, we are designing our program. We are trying to teach our machine to act on that particular, or we can say better, with respect to that particular task. Suppose if you say that try to find out how many students are getting more than 60% of the average students, then that will be a task. Performance, that is P. Performance means if that machine is capable of doing the tasks. But next thing is to that how much accurate it is performing, right? How much efficiently or how much accurately or how much precision it is achieving while performing that task. So we need some measures to exactly measure means or exactly we can say that to find out the accuracy of the machine's output. So these are the performance measures, or you can say performance metrics. Then experience. See, experience like our human being. First time if you cook something, then that may not output as a better recipe, right? Better dishes. But when you do the same thing again and again, if you again you are going to cook the same particular dish, then obviously it may improve over the time, right? Suppose if you run first 5 kilometer, if you first day on the first 5 kilometer, you may feel tired or you may feel some kind of means less energy to perform that. But if you repeatedly do the same thing again and again, then you will improve over time. Similarly, for the machines also, that it will be taught or it will be capable of learning from its previous experiences, that based on those experiences it can improvise its performance. So these three are this way associated: task, performance, and experience. So conceptually you can say that a task is said to be a machine learning based task when it is based on the process and the system must follow for operating on the data points. And the examples of machine learning based tasks are, very famous. These terms we all are aware of. It means the beginner should also know, like classifications, regression, structured annotation, clustering, transcription, etc. Many more other terms are also there, that association, these things, right? So these are the machine learning based tasks. Then experience is the knowledge gained from the data points provided to the algorithm or model. Basically, you have to say data is everything in current day world. Without data, the company would not last, because everything, if you see the Google, if you see that other means organizations, basically they are working only because of the data exists, right? So experience we can directly define on the basis of data, means this experience is nothing but the knowledge gained from the data points provided to the algorithm or model. Once provided to the data set, the model will run iteratively and will learn some inherent pattern, right? And this learning thus acquired will be known as experience. The experience gained by our model or algorithm will be used to solve the task C. Then performance, as I have said, that this algorithm is supposed to perform some tasks and gain experience with the process of time. The measure which tells whether this algorithm, our proposed algorithm or the existing algorithm, is performing as per our expectation or not, is its performance. So P is actually basically a quantitative matrix that tells how a model is performing the tasks. T, using its experience. E, there are many metrics, see, that will help us to understand or find out the ML performance. What are they? Accuracy score, F1 score, confusion matrix, precision, recall, sensitivity. You don't worry, I'll go through each of these terms, each of these performance metrics more clearly in the coming lectures. We'll discuss in depth, obviously, with some practicals, because this particular series is mainly designed to means meet those requirements. Those requirements meet those requirements for doing machine learning using Python. Well, now, what are the challenges in machine learning? So I told you that data is everything. Without data, these algorithms are just void, null and void. So quality of data means what type of quality? Not it doesn't only matter on the quantity. What matters exactly is the quality of data. How good quality data for ML algorithm is one of the biggest challenges, because it is not easy to find out a refined version, or I can say good quality data always. And because of that, we have to perform some pre-processing to make the data, to make it to a good standard, right? Otherwise, use of low quality data leads to the problems related to the data pre-processing and feature extraction. Well, so quality of data first thing, then time-consuming tasks. Another challenge faced by ML model is the consumption of time, especially for data acquisitions, feature extraction, and retrieval. You cannot directly apply that ML model, or means that particular algorithm. First, you have to go from some pre-processing tasks. First, you have to acquire the data, then you need to identify the features, feature extraction, and retrieval. So this kind of tasks takes time. So time consuming is one more challenge. Lack of specialist person. As ML technology is still in its infancy stage, availability of expert resources is a tough job. What exactly it means is ML technology, we are applying it in different fields. That may be a medical domain, medical data, right? That may be a suppose satellite imaging, or there are different specialized fields. Those specialized persons from those fields may not understand this technology in better way that a computer science background people do. So there will be some kind of training or some kind of special knowledge required, and that is obviously a lacking. You cannot say that all the persons can perform means in better in every field. So they should be trained. So that is a challenge. Then no clear objective for formulating business problems. Having no clear objective, well-defined goal for business problem is one more challenge for ML, because the technology is not that matured. Then issue of overfitting and underfitting. This is a very common problem. If the model is overfitting or underfitting, it cannot be represented well for the problem. And what is overfitting and what is underfitting in details we will discuss. Don't worry. Then cars of dimensionality, right? Too many features of data points are there. So the dimensionality, that is that maybe kind of cars means you have to deal with multiple dimensions, and that is not easy to deal with all such dimensions. Then difficulty in deployment. Complexity of ML model makes it quite difficult to be deployed in real life. So these are some challenges: time consuming, lack of specialist person, no clear objective, overfitting and underfitting problems, scarce of dimensionality, and deployment difficulty. Well, there may be challenges, but today's world, we are applying machine learning everywhere. Applications of machine learning you can see, like medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, email spam and malware filtering, self-driving cars. There's a very means you can say emerging example. Tesla or these other cars who are self-driving, they are using machine learning. Then product recommendation, you can see easily on your online shopping site, whatever the products will be recommended that may attract your eyes, because that is from your study on you exactly, what you are surfing, and based on those surfings, they will find you that what products you may be interested on. So that is also a part of machine learning example, right? Application. Then traffic prediction, speech recognition, image recognition, automatic language translation. Here I have to say that one more series is going on in this particular channel, prepare, and that is the image processing in OpenCV using Python. So that series is very helpful if you want to learn more on this artificial intelligence, that particularly the computer vision and image processing part. And there I am showing every practical using Python in OpenCV. So don't miss that series. I will give the link there. Okay. So these are the applications of machine learning. Then I told you that data plays the major part. And what is data set? Data set is the collection of those data. It can be anything like an array, or you can say directly a table, complete database. So we need data, and collection of data is the data set. But there may be different data types like numerical, categorical. From the name itself, it's clear that numeric data, categorical means categorical base, right? Now, ordinal means numeric data are the numbers and can be split into two numerical categories, discrete and continuous. Discrete means what? Those data that are limited to integers, like, number of cars passing by. That is a discrete. But continuous data means what? That can be any number. The price of an item or the size of an item. Then categorical data are the values that cannot measured up against each other. You say suppose color value, or you say yes or no values. These are the categorical. But you see numerical. In the numerical, you find discrete data, you find continuous data. So continuous means, just say price of an item, that may vary, right? Size of an item. So again, discrete means what? Those are kind of number, particular number, say number of cars, number of persons. Those are the discrete data. Then you see categorials are some values like yes, no, like pass, fail. These are the categorical data. Now, ordinal data. What is ordinal data? Ordinal data are the categorical data, are like categorical data, but here we can measure against each other. How? Suppose school grades, where A is better than B, like that. Yes. So ordinal data, don't forget that is a kind of categorical data, but you can measure each means them against each other. An example I have given here, like grades, A better than B, school grade, grade means passing grade is A is better than B, like first class, second class. So in that way. So you have to have a clear idea on this data types, and you now got it. What are they? First, numerical and categorical. Numerical, you have seen that discrete and continuous. Then categorical, you have seen that they are cannot be measured. I mean, they cannot be measured against each other. Like color value, say red and green. Then say yes or no values. These are categorical data. But ordinal data, like categorical data, but we can measure up against each other, like school grades. So these are the different types. Now you have to know about your data type. Then only you will actually means understand that what particular machine learning algorithm that will be need to analyze them or analyze the data more efficiently. So say I think this session is sufficient as the first session. Next session, with some conceptual things, I will also show you the first practical in the machine learning. That's all for today. Thank you.